We are looking at annuities. Annuity is an interest-bearing account. So there's an ordinary annuity with one payment is made at the end of every compounding period. The future value of an annuity, the amount in the account including interest after all payments are made. So we're looking at, for example, in January you make payments of $100 at the end of each month into an account, paying 12% yearly interest compounded monthly. How much will be in the account for a summer vacation beginning on July 1st? These are different from the problems we did in Chapter 8.2 because we are not depositing a lump sum that interest earned for the entire period. We're doing it a month at a time. Instead, we're depositing a series of payments and each payment earns interest for a different period of time. The January deposit earns interest for February, March, April, May, and June. The March deposit will only earn interest for April, May, and June. And if we use the formula for compound interest, we'll find that May's deposit earns $1 and June's deposit earns no interest because you put it in June and you haven't even had that in there long enough to earn any interest. So we can look at the chart here that we have $100 that we put in. At that 1.01 to the fifth, because over 5 months, we get $105.10. For February, it's the same thing, except it's only in for 4 months. For March, it's for 3. April gets 2, May gets 1, and June gets 0. So, formula for finding the future value of an ordinary and annuity looks like this. So we've looked at something that looks similar to this. We've seen the 1 plus r over n to the nt when we were looking at compound interest. We're going to subtract 1 and we're going to divide by the rate and the number of compounding periods again. So A is equal to still to the accumulated value. R is going to be the payment. So instead of doing your principal, it's the payment that you're putting in repeatedly. So it's not one lump sum this time, it's the payments that we put in each time. N is the number of times compounded, and T is equal to time. So example 1, suppose Chris has a daily habit of buying a tall cafe latte that costs $1.95 at Starbucks 6 days a week. If instead he put this money into an ordinary annuity, how much would he have in his account if he deposits his monthly savings in the annuity for 15 years? Assume the rate is 3%. So we're using this big formula here for example 1. And we've got to figure out what all of our values are. So we are looking at, this will be 8.4, example 1. We have A, we have an R, we have a little r, an N, and a T. So we have lots of values. You're going to have to pay attention to what we're doing here. So let's go with the ones that we know easily. So the rate, the little r, is 3%. So that's going to be 0.03. N is, we're doing it for his monthly savings in an annuity. The number of times it's happening, he's doing it for 12 months because he's doing it monthly. And the time is going to be for 15 years. So we need to figure out what R is. So the R is going to be 6 days he goes and buys it, and it's times 4 weeks. So he is, for 6 days a week times 4 weeks in a month, we're looking at 24 times this is happening, and that he is going then, this is actually the number of times, we're going to have to do that and then multiply it by how much he's putting in. That's the number of payments times how much the payment is. He's spending $1.95 each time, so that's a total of $46.80. So we've got to figure out how many times it's happening in your month times your payment. So this will be $46.80. And we're looking to find out what A equals. So our A is going to be equal to that payment of $46.80 times 1 plus 0.03 divided by 12. All of that raised to the 12, which is our N times our T, minus 1, all over 0.03 over 12. Now the hardest part in this is figuring out how to put it in your calculator. If you put it in the calculator, make sure that you parenthesize this entire top and you parenthesize the bottom. I'm going to tell you what your answer should be, and you're going to need to practice with this to make sure you get it. So you might need to add in a parenthesis here and a parenthesis here. So you take, and you might want to do the multiplication last, so put all of this part in parentheses, divide by this in parentheses, and then multiply by the 46.80. On a test, most of this is going to be where most of your points are. The final answer is like worth a point, so don't freak out if you can't get that final answer. So your final answer should be 106.22.32. So $10,622.32 is what you're looking to find at the end of 15 years, just by not buying your latte and instead investing it. All right, the next thing that we have is a sinking fund. A sinking fund means you intentionally set aside money towards a big financial expense. For example, the gradual repayment of a debt to fund a future expense. It is a special type of annuity where we know A and want to find R. So assume that you wish to save $1,800 in a sinking fund in 2 years. The account pays 6% compounded quarterly, and you will also make payments quarterly. What should be your quarterly payment? So we're looking at what we know versus what we're trying to find. We're looking for the quarterly payment, so that means we're looking for the R. So this will be example 2. Again, A, our big R, our little r, our N, and our T. We're still using our really big formula. Our accumulated value that we're looking for is $1,800. Our rate is 6%, which gets us 0.06. The number of compounding periods is quarterly, so we know that's 4. And T is going to be 2 because we're looking for it to happen in 2 years. So in this case, we're going to have 1,800 because we're using the same big formula. 1,800 is equal to our R times our 1 plus our 0.06 over our N raised to our N times our T minus 1 all over our 0.06 divided by 4. And remember, if you're plugging this in the calculator, you're going to want to pay attention to these extra parentheses in there. So if we're looking at the R, we're going to have to divide both sides by this big part here. So we end up with R is equal to 1,800 divided by our 1 plus 0.06 over 4 raised to that 4 times 2, which we could write as 8, minus 1, all over 0.06 divided by 4. And when you do that, you should get 213.45. So again, practice with your calculator. You're probably going to need to use a regular calculator and not the one on your phone, because it might be harder to do on your phone. And again, we're using this big formula right here. to do these. All right, for example 3, I'm going to give you an example. I want you to work on setting it up and seeing if you can figure out what it should be. We're finding the ordinary annuity value. The amount is $400. The monthly interest rate is 9%, and the time is 4 years. So the amount is going to be $400. You want to find the value. This is the amount you're putting in each time. So if you want to pause and try to do this, I'll still show you how to work it. That way you know. But that way you can try this one and see if you can set it up. So we're going to use the same formula. So pause at this time and work it on yourself if you'd like. So example 3, we are looking for our A, our big R, our little r, our N, and our T. Now this time we're just told what R is. R is $400. We don't have to go find it. We don't have to figure it out. We are told that the rate is 9%, which becomes 0.09. Our N is 12, and the T is equal to 4. So now we just plug it in our formula. So A is equal to 400 times 1 plus 0.09 over 12 raised to the 12 times 4 minus 1 all over our 0.09 over 12. And when you find that, your A should be $23,008.28. All right. And on example 4, find the sinking fund monthly payment compounded monthly. So again, you can do this one on your own and then see if you can figure it out. So here we are given A is equal to 10,000. That's going to be the accumulated value. We are looking for the monthly payment, so we're looking for big R. Little r is 6%, T is equal to 5, and N equals 12. All right, so on example 4, A, R, little r, N, and T. So big A is 10,000. Our little r is 6%, which becomes 0.06. Our N is 12, because it's monthly, and T is 5. All right. So we're starting again with the same formula. So our 10,000 is equal to our R times 1 plus 0.06 divided by 12 raised to the 12 times 5 minus 1 all over 0.06 divided by 12. So again, we're going to have to divide by the whole big part. So R is equal to our 10,000 divided by our 1 plus 0.06 divided by 12 raised to the 12 times 5, which we could write as 60 to make it a little bit easier in the calculator, minus 1 all over our 0.06 divided by 12. And when you do that, your R should be equal to $143.33.